A hallmark of American infrastructure is just its sheer ambition. And if you've ever driven across one of those massive bridges, you've probably had that thought. How on earth did they build those colossal support columns right in the middle of the water? It honestly seems impossible, but it's one of the greatest feats of modern engineering. And today, we're going to pull back the curtain and see exactly how it's done.
This right here is the fundamental puzzle. I mean, you can't just pour a bunch of concrete into a river and hope for the best, right? You have to create a perfectly stable, solid base on a seabed you can't even see, all while fighting the relentless, crushing force of the water itself.
And this is way more than just fighting a little bit of motion. It's a full-on underwater battlefield. Engineers are going up against the crushing weight of water, crazy unpredictable currents, soft, mucky seabeds that offer zero support, and of course the constant threat of powerful waves and corrosive salt water. It's a truly hostile environment to work in. So how do they win? Well, the secret isn't really about overpowering the water with brute force. It's about using these incredibly clever strategies and some really ingenious inventions to work around it, to tame it, and ultimately to build structures that are going to stand for centuries.
Okay, so let's look at the first and, honestly, the most direct approach. If water is the problem, what's the simplest solution? Just get rid of it. Essentially, you create your own private island of dry land right where you need to build.
And this is done with something called a cofferdam. I want you to think of it like a giant, temporary, watertight retaining wall. It isn't part of the final bridge. It's basically a construction site that you build in the middle of a river, which lets the builders work just as if they were on solid ground. The process is just fascinating. First, they take these massive interlocking steel sheets and drive them deep into the seabed to form a wall. Then, they build this complex web of internal braces to stop the walls from collapsing inward from all that water pressure. And then, the magic moment, they pump all the water out. And just like that, it's a regular construction site. Except, it just happens to be at the bottom of a river. But a cofferdam isn't always an option. I mean, what if the water's too deep or the currents are just way too strong? Well, in that case, if you can't get rid of the water, you've got to go right through it and anchor the foundation deep, deep within the earth itself.
And this method uses something called piles. The best way to picture them is like gigantic stilts. You're not even trying to build on the soft, unstable mud of the seabed. Nope, you're punching these long, incredibly strong columns through the water, through the mud, through the sand, all the way down until you hit solid bedrock.
The process is just so powerful to watch. A huge hydraulic pile hammer or a high-frequency vibrator just drives these steel pipes downward, sometimes hundreds and hundreds of feet. Once a pipe hits that unyielding layer of rock, it's filled up with steel rebar and concrete. And what that does is create a foundation that's directly connected to the strongest part of the earth, completely bypassing that unstable seabed.
All right, this brings us to a third solution. And this one, it might be the most mind-bending of all. Instead of building the foundation in the water, what if you built a massive piece of it on land, floated it into position, and then just sank it?
This method uses a caisson. It's basically a giant hollow concrete box that's open at the bottom. But here's the key difference. Unlike a cofferdam, the caisson isn't temporary. It becomes the permanent base of the bridge column itself. This is just engineering ingenuity at its absolute finest.
It's really incredible to see how this technology has evolved. Historically, working in caissons was actually lethal. I mean, during the construction of America's Brooklyn Bridge, for example, dozens and dozens of workers suffered from decompression sickness, what they called the bends. But today, the whole process has been revolutionized. They pump compressed air into the chamber, which pushes the water out and creates a safe, dry work environment deep beneath the surface.
So here's how it works. After the caisson is sunk, workers or machines inside start digging out the soil from underneath it. As they dig, the massive weight of the caisson itself causes it to sink deeper and deeper into the seabed. And once it reaches a stable, solid layer, the entire hollow structure is filled with concrete, turning it into one massive, immovable block, the perfect foundation for a bridge pier. So we've covered the theory, right? But where can we actually see this in the real world? Let's take a look at a spectacular marvel of American engineering where these exact techniques were put to the ultimate test. This quote just captures the challenge perfectly. See, there's no single magic bullet for building in water. As we're about to see, engineers need a full arsenal of solutions, especially when they're tackling one of America's most ambitious crossings. We're talking about the Chesapeake Bay Bridge Tunnel in Virginia. This thing is an absolutely incredible structure. It's a testament to American ingenuity, stretching for miles and miles across the open Atlantic, connecting land masses with a combination of both bridges and underwater tunnels.
The engineers who designed this faced an incredible set of challenges. They weren't just crossing some calm river, they were building in deep ocean channels with powerful currents, high winds, and massive waves, all while needing to leave room for these huge naval ships to pass right through.
So the big takeaway here is that they couldn't just rely on one method. The construction of the Chesapeake Bay Bridge Tunnel was a masterclass in combining techniques. They drove thousands of concrete piles for the long trestle sections, and they built these massive artificial islands to serve as the portals for the tunnels, likely using variations of cofferdams or caissons. It's the perfect showcase of how this whole engineering toolbox comes together to solve complex, real-world problems.
So the next time you drive over a bridge, just remember, the towering columns and the sweeping cables you see, that's only half the story. The true marvel, the real battle against the impossible, is hidden deep beneath the water's surface. And it kind of makes you wonder, what other feats of hidden engineering do we pass by every single day without even realizing it?